Okay, today we're going to talk about electron configuration and orbital notation. To understand this, you have to understand S, P, D, and F. These each have 2 electrons in each of their levels. S has 2, P has 6, D has 10, and F has 14. Electron configuration is the distribution of electrons of an atom in orbitals. This has to do with the sublevels. Francium, which is going to be our example, is what we're going to learn how to do electron configuration with. Electron configuration is basically how you categorize a group of levels. Francium is way down here at the bottom of the table. How are we going to figure out how to do it? Well, by using electron configuration, we can easily figure out how many sublevels it has and what it ends on. The S, as I said, it has 2 sublevels. 1, 2. So you read this like a book, and you go 1s, 2s, 2s, 2s squared, 2p to the 6, 3s squared, 3p to the 6. You just count the elements that are highlighted in the different colors. Each different color has to do with the different sublevels. So if you're going to do this for francium, this is the electron configuration for it. Francium, however, is kind of special because as you notice once you get down here, these are all a little bit funky. And you have a 4s, which is like, what in the world are you doing? Well, francium, you go, and you read it like a book, you go 6x, so you have 6s squared. You go 5d, so you have the 5d1. But you have to follow the path. And so all you go down to 4f, and 4f has 14. Then you have to finish what you started, and you go 5d9. And then you finish 6p, and then you end at the 7s1. 7s1 because it's in that first column, not the second one. It's not in the second column, so that's why you do that. For shorthand notation, it's pretty simple. As you can see over here, I've highlighted the last column. These are known as noble gases. They have the most stable, and they don't want to bond with other electrons because they have 8 outer electrons, so they're full. To do this, you find the closest noble gas to your element, which would be radon. So you write radon, and then you write whatever many sublevels it takes to get. For francium, it's just 7s. Now, on the orbitals, you have to understand the electron configuration. For this, it's very simple. So you just go up, and then you go down. So, first you go to 1s, then you go to 2s, then you go over to 2p, then 3s, then 3p, 4s. You work your way up kind of like a staggered amount of stairs, and then you get all the way over here. You have to make sure you always go across before you go down. And as we said, we ended on 7s to the first power. And that is how you do orbital notation and electron configuration.